Hello everybody, and welcome to the next video in our GMAT Ninja Quant series. My name's Harry Duthie, and today we're going to be taking a look at the next video in our word problem section. We'll be looking at percentages. We're going to be starting right at the beginning, looking at the basics of percentages, how to use them, how to convert them between fractions and decimals. I'm going to be working right through to the compound interest questions towards the end. Now, before we get into this, I'm going to give you an idea about the difficulty rating of this video. We'd probably put this somewhere in the middle. So if you're in the 30s or the 40s and you've struggled with percentage questions, then we're probably going to have a few things for you here. Now, while the start of the video starts out very foundational, we're going to be looking at the basics of everything. The second half of the video, the difficulty level is going to ramp up, and there's going to be a couple of questions towards the end that will really challenge you unless you're in the high 40s already. Just as a warning for those of you that are in the 48, 49, 50 region already and are looking for questions, the very difficult questions that are going to push you onto a 51, we probably don't have much for you today. What we're looking for, the people that will really benefit from this video are the ones where if you're looking at a percentages question, you're just confused by the phrasing of it. If you're not really sure where to begin, then we're definitely going to have a lot for you, and stick around certainly for the beginning of the video. The next group, if you've memorized all the formulas, like if you know that compound interest formula, but you're still missing a frustrating number of questions, then we're going to be looking at breaking those formulas down, breaking the processes down, and having a look at the why behind these questions. And so, yeah, if you fit into this box again, we're definitely going to have some stuff for you here. And all of this falls into these two bits. If you don't really understand percentages questions, but you're just relying on some tricks to get you through them, then, as I said before, we're going to break some of these questions down, tell you what to look for and how to look for it, and we'll certainly have a few things to help you. And this all comes under the category of if you know everything, but you're still struggling with percentage questions and you're not really sure why. If you fall into any of these four categories, then this video is definitely for you, and please stick around. We're going to see what we can do to help you out. Now, I've got 9 questions for you today, and the way we'll do this is I will put a question up on the screen and give you a couple of minutes to take a look at it. Then I'll come back, we'll take the question away, and we'll work through it together on the board, and I'll try and explain it in a way that helps you better understand what it is you should be looking for and what it is you should be doing in the question. Within those questions, we're going to cover, as part of them, translating word problems into math speak. This is a feature of our word problems series that we're doing within the overall quant series, that if you can be as literal as possible with some of these questions, it makes it easier to translate the text into algebra, and we'll have a look at what I mean by that later. We'll get into just percentage changes, single or multiple percentage changes, finding a percentage of something, or increasing or decreasing something by a percentage. But this is the big thing for this video. And this is one that I'm going to be really pushing throughout the entire next hour, hour and a quarter, however long it is, how to make fractions your friends. If you're not comfortable with fractions, then percentages are going to be very difficult. So yeah, if that sounds like you, then I'd take this as a bit of a warning that maybe in the next few days, you're going to want to do a lot of work on fractions, and that will definitely help you understand percentages better. And then we've got this bit looming at the end, the compound interest formula. It's not the most important thing, but it certainly makes a lot of people nervous, and we're going to go dig into the details of that. All right, so without any further ado, I will get the first question up on the screen. I'll give you a couple of minutes to take a look at it, and we'll see you back here soon so we can go through it together. Okay, I hope you've had enough time to take a look at this one. If you feel you need a little more time, if you've not quite got to your answer yet, then feel free to pause the video now. We'll still be here when you're done. But for now, I'm going to take the question away so that we can take a look at this one together. Now, as we set up at the start of the video, a lot of the challenge in some of these questions, is translating the text literally into algebra. Now, we've done a full video on this already, and if you want to go take a look at our algebra translations videos after you've watched this one, then that'll give you many, many more examples about putting this process into action. But we'll take a look at how it's put in place in this question, and we'll use that technique again and again and again as we go through the rest of this video. Now, the big clue to get this question going is this final sentence. The fox ate what percentage of the hens? That's the question. And the challenge is to translate that into algebra. So I've rewritten this up at the top left, and we're going to just go word by word, converting this from text into algebra. So the first section, the fox ate. Well, from the question, we were told the fox ate 16 hens. So the fox is going to eat 16 of these hens. Now, the next bit, what percentage? So I've got an unknown percentage here. That's basically the question. So let's just come up with some sort of letter, and I'm going to call that P%. And the percentage, so P% there. Now, the word of, when you're converting text into algebra, the word of you could just substitute for a multiplication. And then the hens, we were told that there were 800,000 hens in this hen house. And now we end up with, the word 16 P% times 800,000. We say, well, 16, that is equal to P% of 800,000, because that's what we're defining the question to be. We want to know what percentage of the hens the fox ate. We know the total was 16, and so we can put an equal sign in between there. 16 is equal to P% of 800,000, and the question here is, what is P? And so now that you've translated this literally, we've got the beginnings of an equation there, and we just need to tidy this up into a full algebraic expression. So the 16 doesn't change here. The only real change is this bit, P%. Whenever you see something like P%, X%, R%, 10%, 5%, whatever it is, then that percent means you're going to put something over 100. And that's very important. This is one of the areas that lots of our students make those small, unnecessary mistakes. Everything else they do is absolutely spot on. The algebra's fine, the understanding of the concept's fine. They just forget to put something over 100, and that ruins the solution. So whenever you see, as I say, P%, that is another way of saying P divided by 100 when you're converting that into algebra. Then we've got our times 800,000 on the end, and now I've got an equation. Now, we can begin to solve this. First step, I'm going to cancel out a couple of zeros here. So we get 16 is 8,000p, or dividing both sides by 8,000, I'm going to have p is 16 over 8,000. Now, as we've said before in some of these videos, at this stage, you don't need to be able to do 16 divided by 8,000 straight off the bat. You could just begin to cancel down top and bottom. What's a number that divides both 16 and 8,000? Well, yeah, there's a variety of them. I'm actually going to go with 8. So 16 divided by 8 will give me 2. 8,000 divided by 8 will give me 1,000. I could have done it. I could have divided top and bottom by 2, by 4, by 8, by 60. It's just a case of don't think you have to get to an answer in one step. Just start cancelling, work your way through, be calm, be measured, but don't waste time, and you'll get to an answer in the end. It'll probably be much more accurate than you just trying to jump there in one step. So now 2 divided by 1,000. Again, I could divide top and bottom by 2 here, but just looking over, I've got all my answers in decimals. So why don't I take that 2 and divide it by 1,000, and I'll get p is 0.002. So now I've got a value for p, and the final question is, do I need to do anything more with it? Another place in a question like this that some of our students fall apart is that, well, they'll say that p, I found p, but to make it a percentage, I've got to times it by 100. I'm going to say no. What we did at the beginning was define this as p%. So whatever p is, that is the percentage I'm looking for. We already put it over 100. We've already baked in the percent part into this problem. And so I can just take this number and go and find the answer choice that matches it, in this case, D, and that's going to be my answer. Right, so the challenge in this one was converting the text straight from the great big wall of writing that the question gave you into this algebraic expression that we could go and solve. Now, as you can see, once you get the equation up there, the algebra is not that hard. And in a lot of these word problem cases, that is the challenge. 70, 75%, something like that of the question is done by the time you get the algebra on written down. If that process is still a challenge, if you didn't really follow what I was doing there, then as I say, we've got the algebra translation video that'll include another 8 or 9 examples of putting this process into action. And at the end of watching this one, maybe go and find that one. And as I say, there'll be more examples for you there. In the meantime, we're going to keep going with the percentages topic, and I will get the next question up on the screen for you. I'll see you back here in a couple of minutes' time. Okay, now's the time to pause the video if you need a little more time to look at this one. For now, I'm going to take it away so that we can take a closer look at this question together. So, of the two things we said up at the start that we're going to make a big deal of in this video, the algebra translations and making fractions your friend. We're going to really use fractions in this question. Again, they're going to be used throughout this video. So now's a good time to sort of pause and say, well, okay, which are the big conversions you should be able to do? And yeah, what are the percentages and how do they link to fractions? Now, there's very few things that we really ask our students to memorize when we're getting ready for the GMAT. We try and stay away from formulas because when it's question 30 and the clock's ticking away, the pressure on you is likely to make you misremember the formulas in some respects. But there are a string of percentages that are very helpful to know, and if you can convert between percentages and fractions, your life will be so much simpler. So we've got some of the easy ones, like 50%. 50%, that's just a half. Most people know that. In the same way, 33 and a third as a percentage, that's a third. If you convert that to a fraction, 25 is a quarter, 20% is a fifth. Those are the ones that most people are very comfortable with. The next three are ones that fewer people are aware of. 16 and 2/3% as a fraction, that's a sixth. 12.5%, that's an eighth. And 11 and 1/9, that could be a ninth. And then we're back to the simpler ones that most people know. 10% is a tenth and 5% is a 20th. Now, if you're aware of these fractions and you can very quickly convert between them, then your life will be made easier in percentages. But we can go a little bit further. These are the bases. And in particular, for this question, I want to take a look at 11 and a ninth. As we said, that's 1/9%, but you can begin to get multiples of this. So 22 and 2/9 as a percentage, that's 2/9. 33 and 3/9. Well, that's 3/9, which is a third, which is what we've got here. 33 and a third is the same as 33 and 3/9. But the big important one for us right now, 44 and 4/9 as a percentage, that's going to be 4/9. And we're going to make use of that as we get into this question. So just as an aside, these percentages and the conversions between percentage and fractions, very useful for dealing with percentage questions. And if you don't know these, I suggest you spend a little bit of time memorizing them, and you will see as we go through the rest of this video how helpful they can be. Now, as I said, we're going to use that in this question, and I come to the question now. Eventually, I want to know what was the percentage change in internet users from 2000 to 2003. But for now, I'm going to ignore that part of the question and just look at this bit at the top. So in 2000, the number of people using the internet was 44 and 4/9%, so 4 over 9, if we convert that into a fraction, of the number in 2003. Now, I don't have any numbers to put here. And again, one of the themes of this video is going to be, please stay away from just launching numbers in and hoping they'll work out. I don't want to say there were 100 internet users in 2003. As you're going to see as we get later on, that way of thinking is going to get you in a lot of trouble. I'm just going to put some sort of unknown there. I don't know how many there were in 2003, but I know that the number in 2000 was 44 and 4/9% of that. And our conversion says that that's 4/9 of that number. So 44 and 4/9% of the number would be 4/9 of the number, or 4/9 of x. So the number in 2000 is 4/9 of the number in 2003. Now I want to reverse that. I want to know what the percentage change in internet users from 2000 to 2003 was. So what I'm going to do is I'm going to say that that x there, I want to make that the subject of this transformation from 2000 to 2003. So if I have the 4/9 multiplied by the x, in order to make this x the subject, I'm going to times both of these by 9. So 4x to 9x there, and then divide both of them by 4. So x to 9 over 4x. Or in other words, to go in this direction, I times the x by 4 over 9. To go in that direction, I times it by 9 over 4. So in 2003, we actually had 9/4 of the number we had in 2000. Now that's not us done, because I don't want to know what percentage of internet users. I want to know what the percentage change was. And so we need to think about this in a slightly different way. This 9 over 4x, well, I could think about that as the x plus 5 over 4x. This is the original. This is the change. And so what can I make 5 over 4 into a percentage? Well, as we said, 1 over 4 was 25%. 4 over 4 is going to be 100% because that's full. So 5 over 4 is going to be 125% of x. So the percentage change is going to be 125%, which is D. Right, so there's a few places you can slip up in this question. As I say, once you get it into fractions, it's much nicer. This way of thinking about the conversion back and forth steers you away from these two answers at the beginning. Yeah, if this is 4/9, you don't just add 5/9 to get back to the original. This is more about multipliers. I want you to always be thinking about multiplying from one way to the other when we're dealing with percentages, rather than just saying I'm going to add 5/9 on that I had before. That's not going to work in this scenario. And then this bit, yeah, separating that 9 over 4 into the two values because it said percentage change. And be very careful with the wording in these questions. They're not trying to trick you, but if you're not paying attention, you can just slip and go down the wrong path. All right, so as I said, the big thing about this one is translating literally and using fractions, and we're going to get that into more of the questions as we go through. I'll get the next question up on the screen, and I'll see you back here in a couple of minutes' time. Okay, I hope you've had a little more time to look at this one. If you need any more time, feel free to pause it now, but I'm going to take the question away so that we can look at it together. Right, so we've got a few things going on in this one. We're going to have to find two different percentages, push them together, and then at the end figure out another percentage change. What percentage higher at store C than at store B? But before we get to that final bit, we've got to look at the difference between store A and store B. And there's something in the wording of this question that I want to take a look at. As it says here, I've rewritten bits of the question. The price at A is 25% higher than at B. Now, just this phrasing, again, begins to confuse some of our students. Yeah, the difference between price at A is higher than at B and A is some percentage of B. And this is one of those scenarios where I will take a question and always rewrite it so that I'm doing the same process every time. In this case, the price of A is 25% higher than the price at B. Well, then I could say the price at A is 125% of the price at B. Because if it's 25% higher, then we get the price at B plus 25% of that. So the original price is 100% plus the 25%. So it's 125% of the price at B. Now, the reason I do that is mainly just so that I'm doing the same thing every time. And because that word of, it just means multiply. So the price at A is equal to 125%, so 125 over 100 of the price at B. Or I could simplify that. A is 5/4 of B. And I've got myself a very simple equation that I can work with there. And it's all in the wording of the text, so I can translate directly from the price at A is 125% the price of B. It's much harder to translate the price at A is 12.5% higher than at C directly into algebra, again, which is why I'm rewriting these. So for the second one, if the price at A is 12.5% higher than at C, then we get the original 100% of C's price, and we add on 12.5%. So the price at A is 112.5% of the price at C. And again, I can convert that more directly into algebra. So A is 112.5 over 100 times C. Now, this one might be a little more difficult to convert straight in or to simplify down. Yeah, if you need a bit more time to do the cancelling, go for it. But if you can see that 12.5%, or if you can remember from the last question, 12.5% was an eighth. In this case, we've got the whole of C, 8/8 plus one more. So this is A is 9/8 of C. And so by taking the question, rewriting this bit about some price being higher than another bit as to being some price is this percent of the other bit, you can much more quickly convert into algebra, and that'll give us a couple of nice equations that we can go and use. So we know that A is 9/8 of C, and we know that A is 5/4 of B, and I want some relationship. So the question now, the price of the shirt is what percentage higher at store C than at store B? So I'm going to want to get C and B into a single equation with no A in there, and then I want to get C equals something, and that'll give me something to work with. So I've got two equations here. I've got A equals something and A equals something. So I can push these two bits together and say 9/8 of C is equal to 5/4 of B. Now, as I said, I want to make C the subject of this. So if I multiply both sides by 8, I'm going to eventually going to get 10B. And then divided by 9, C is 10 over 9B. Now, yeah, 10 over 9, if I was to convert that into a percentage, that's going to be more than 100, which is none of my answers. Thankfully, this question is about what percentage higher. So again, I could rewrite that 10 over 9B as the original plus 1 over 9B. It is this much higher than the original. That's the bit I'm looking for. Now, yeah, in the last question, we said that 1 over 9 was equal to 11 1/9%. So we could say that C is equal to B plus 11 1/9% of B. And so C is 11 1/9% higher than the price at B, which means that the correct answer here is C. So one of the things we do when we're dealing with word questions like this, and it'll definitely come back in number properties. This is the other obvious place of doing it, is to rewrite the question so that the translation from the text into algebra is more literal. And if you can get the hang of saying, well, yeah, A is 25% higher than B, that means A is 125% of B. Or the reverse, if A is 25% lower than B, then A is 75% of B. In that literal translation, just because the word of means multiply, you can create these equations with the fractions that work much more simply than those fiddly ones with lots of percentage signs, and it's just an easier way of dealing with them. You want to be doing the same thing every time so that when the time pressure is on towards the end of the quant section, you don't get muddled up between two different processes. That's why I always rewrite them this way, and hopefully that can help you too. All right, I'll get the next question up on the screen, and I'll see you back here in a couple of minutes' time. Okay, now's your chance to pause the video if you need a bit more time to look at this one. I'm going to take it away so that we can take a closer look. Okay, the big things in this question are bringing some of the things we've looked at in the last two problems together. So we're dealing with percentage changes, we're dealing with the change in the text, and we're putting it all together into one equation here. What we're looking at is the firm's revenue, and we want to know what percentage of it was it this year or the year in question compared to the previous year before the changes, before they charged more money and sold fewer hours. So the first thing we need to do is we need to come up with some sort of equation for the firm's revenue, because that's what we're looking at. Now, in this question, all we're told about is the number of hours that the firm sold and the cost per hour. So our revenue formula is going to be, let's say, N for the number of hours the firm sold multiplied by the cost. Now, we could say that this is the revenue for the previous year. Again, I could put numbers into this, but if I go down that path and make that into a habit, I'm going to run into a lot of trouble. What I want to do here is stick with algebra, and I'm going to say that was the previous year. And I'm going to make some changes and see what the revenue's like in the new year. So I'll still use the revenue, but we'll say this is the revenue for the new year. Now, during this year, the firm raised its hourly rate by 40%. So we could look at the cost value. The cost value in our new year is going to be 40% higher than it was the previous year. Or, if you remember back to what we were doing in the last question, 40% higher is the same as 140% of the previous year. So I could say that my new cost per hour of consulting is going to be 140 over 100 times by C. I could do a very similar thing with the number of hours of consulting. We're told here they sold 30% fewer hours. 30% fewer, that's it. The old value is 100%. I take 30% off that. My new value is going to be 70% of the previous value. And so number of hours is going to be 70 over 100 times by N. And so this whole expression, I can simplify the 7 over 100, sorry, 70 over 100 to be 7 over 10. I can simplify the 140 over 100. That'll actually cancel down to be 7 over 5. And then I've got the n and the c. Now we can do the multiplication here. 7 times 7 will be 49. 10 times 5 will be 50. And just because I'm working with percentages here, I could multiply the top and bottom by this fraction by 2 and get 98 over 100 times n times c. So this new revenue value that we've been working out is 98 over 100 times by nc. Now the nc, that's the old revenue value. So the new revenue is 98 over 100 times the old revenue value. Converting this into a percentage, well, we've got 98 over 100. As we said way back in question 2, a percentage is just defined as something over 100. So we can, again, literally rewrite this as the new revenue is 98 over 100, 98% of the old revenue, which means that our answer here is going to be B. Now, full disclosure with this one, this is one of those questions where you could have taken the old revenue and picked a number, said it was 100. Fine, yes, it will work in this question. But as you're about to see in the next few questions, if you were to try and do that elsewhere, you're going to get into all kinds of trouble. And as we've said before, one of the things that we really push is to make sure that you have a technique that will work in every question, so that you're never stood there at the start of a question just going, is this one where I should use algebra? Is this one where I should pick 100 and see where it goes? It's safer and you'll do less thinking. You'll be less stressed if you just do the same thing every time. So if I can convince you of one thing in percentage questions using this video, is to please not throw numbers at it and just see where it goes. Stick to algebra, stick to general arguments if you can. And as you can see with this one, it can actually work out very nicely. All right, and so on that theme, I'm going to get rid of this question. We'll get the next one up on the screen and I'll see you back here very soon. Okay, now's the chance to pause the video if you need a little more time to work on this one. I'm going to take this away now so that we can take a closer look. So these questions about products being bought at stores and they're given discounts, or they're being increased and then they're being sold at a markup, or they're marked up then discounted, the actual algebra behind them is usually not particularly difficult. The problem with these questions is keeping track of the variables and what you're doing with them. So I'm going to be very careful with how I define things and the way we build this question up, so that you can see the simplicity in the question and the places where you might go wrong. So to begin with, I'm just going to work through the text here. A store brought a product. Okay, so the cost price to the store, I'm not given a value for that. I don't know what it is. I'll just call it C to begin with. We know that it has some recommended retail price of $150, right? The next sentence tells us that the store sold this product at a 40% discount. Now, you're going to get sick of hearing me say this as we go through the video. 40% discount means 40% off the original price. So 100% take away the 40% gives me 60% of the recommended retail price. My sale price is 60% of 150. Turning that into algebra, 60 over 100 times 150, and you can work that out that the sale price is going to be $90. Now, we're then told that the store made a profit, a 150% profit on the wholesale cost. Or in other words, the profit is 150% of the wholesale cost. So my profit, that's going to be 150% of C, or just 3 over 2 of C as we're simplifying that down. Now, what I want to get to as we go through this is what was the store's profit as a percentage of the recommended retail price? So the two things I need are the store's profit and the recommended retail price. Well, I've got the RRP, I've got the retail price. I need to find the profit. Now, that may involve finding the cost as we go. What I can do with this is to say that my profit, well, that's going to be my sale price minus my cost, how much money I've got coming in versus how much money I paid for the item to begin with. Profit, we know that's 3 over 2C. The sale price, I already know that's 90. I don't know what the cost is. So now I've got an equation just with one variable in. I can use this to go and find C. So adding C to both sides will give me 5 over 2C equals 90. And going to calculate this value will give me that C is equal to 36. Now I know my profit here was 3 over 2 times C. So 3 over 2 times 36 will give me a profit of $54. And now I've got the two values I need. I've got the profit, I've got the recommended retail price, and I want to know what was the store's profit as a percentage of the recommended retail price. Or in other words, I can just say that the value I'm looking for is 54 divided by 150 multiplied by 100. The profit divided by the recommended retail price times 100 will give me the percentage of the recommended retail price represented by the profit. Now it's just a case of simplifying this expression down. Well, 100 over 150, that's the saying is 2/3. Divide 54 by 3, I'm going to get 18. Times it by 2 will give me a final value of 36. And so my answer here is C. So as I said with these questions, this is all about being very, very careful with how you define the variables. And you see, I've taken a fair bit of time to write all this out. That might feel like it's going to take a long time in the exam, but it'll mean that you don't ever get confused between, well, what did I do with the sale value? Which is the recommended retail price? What value goes where? Because as you can see, by the time we get down into the algebra, this is not difficult. But the challenge is avoiding getting muddled as you go through. And if you take the time to be very clear about what you're doing, then this question is not too bad. All right, I will get the next question up on the screen and we'll see you back here in 2 minutes. Okay, I hope you've had enough time to take a look at this one. If you need some more time, now's the time to pause before I take this one away. Okay, this is another question where there's a lot of work to do, and we need to be very systematic in how we go about it, because otherwise we're going to get in a huge muddle. Now, I've said in previous questions that I would avoid picking a number to start with and using that to judge percentage changes as we go through. This is a prime example of where that will get you in serious trouble. For example, let's say you pick 100 for your start point. Okay, then the value of this goes up by 20% in the first year. That's not too bad. We know we've got $120. Then it's going to go down by 25%. Then it's going to go up 16 2/3%. Then it's going to go down 11 1/9%. You're going to end up dealing with something like $74.23 and then trying to raise that by 33 1/3%. Like, the numbers there are going to get horrific very quickly. What I would suggest you do with a question like this is we're going to stick to algebra, as you can probably expect from what we've done so far. I'm going to say that my starting value is just some unknown, x. And then we're going to use the multipliers that we have done before. And again, just be very careful with the algebra as we go through. So in year one, I'm told that the value of the asset increased by 20%. So if, as we've done before, if I increase by 20%, then that's the same as having 120% of the original. So what I'm doing here is 120% of the original, which simplifies down to 6/5 times x. Now, the question's asking on which of the following dates was the asset closest to its original value. So I can see what's the difference between its value at the end of year one to the original value there. And the difference, I'll have a little column over on this far side. The difference here is 1/5 of x. Again, I don't know what x is, but I can use this column to compare the different years and see how close they were to that original value. So I know at the end of year one, the value of the asset was 6/5 times its original one. And then in the second year, it's going to decrease by 25%. So again, turning this from a decrease into a percentage of something, if I decrease the value of something by 25%, I have 75% of its original. So year two, I would have 75/100 times by 6/5 of x, what I finished with at the end of year one. Now that simplifies to 3/4 times 6/5 times x, which will end up being 18/20 times x, or 9/10x. So the difference now between the original value and my year two value is only 1/10 of x. They are 1/10 apart. And so I can see year two is closer to the original value than year one. Because year one, I'm 1/5 of x away. Year two, I'm 1/10 of x away. I'm closer in year two. So I know that A is not going to be the answer. And this is the sort of process we're going to go through for the rest of these. But I'm going to speed things up a bit so you can see where this ends up. In the third year, the value is going to increase by 16 2/3. Now, if you remember back to when we had that list of percentages in question 2, 16 2/3 is the same as 1/6. I'm going to increase the value of this by 1/6. Now, if I increase it by 1/6, that means I have 7/6 of the original. So in year 3, I'm going to have 7/6 times 9/10 of my original. Now, the numbers are going to get pretty nasty here unless I start cancelling some things. Well, I can cancel this 3 on the 9 and the 6, and that will mean that this will end up being 21/20 times x. And so the difference between this value and the original is going to be 1/20 of x. Now, I just need to do the same thing for the fourth and the fifth year. In the fourth year, it's going to decrease by 11 1/9%. Or I'm going to decrease this value by 1/9, which means I have, in year 4, 8/9 of this 21/20x. Now, again, there's things that cancel here. I could divide by 3, top and bottom there, and I could divide by 4, top and bottom there, which would leave me with 14/15x. And so the difference between year 4 and the original is 1/15 of x, and I've got one more to go. In the final year, I'm going to increase it by 1/3. Increasing something by 1/3 means I have 4/3 of my original. Now, in this case, there's nothing that cancels here, so I'm just going to have to multiply and say that's 56/45. x, which means the difference here is going to be 11 over 45x, which is much bigger. Like the difference here, if I multiplied that up, that's 3 over 45x. So year 4 is definitely closer than year 5. So E is definitely not my answer. As we said, year 2 is closer than year 1, so A is not my answer. But 1/20th is closer than year 2, and 1/20th is closer than year 4. So in this one, the correct answer there is C. Now, as you can see, that yeah, there is a lot of work in this question. There's no way around it. You're going to have to do some fraction multiplication here. But this way of having an unknown as your starting point and then treating everything as fractions, just using constant multipliers, you're setting up a multiplier, cancelling wherever you can, making the fractions as simple as possible. This will give you a way of looking at this problem that is much simpler than saying, okay, if my start point is 100, what do the values become as we go through? So as we've used a lot of times up till now, we're constantly trying to use fractions in these questions, trying to cancel wherever possible and make the fractions as simple as possible. Because when we get into the next question that begins looking at compound interest, that's where this is going to become very helpful. All right, so I'm going to get the next question up on the screen. I'll see you back here in a couple of minutes' time. Okay, now's your chance to pause it if you need a little more time with this question. I'm going to give you another second before I take it away and we take a look at this one together. All right, so we're beginning to look at interest rates now, which obviously comes under the banner of percentages here. First thing I want to take a look at is what the difference is between a simple interest rate and a compound rate. So we're going to use this question in order to drive this. I'm actually going to look at Pavel's investment first, and then we'll go and look at Vlad and his compound interest. So Pavel invests $4,000 at a 5% simple annual interest rate. Now, simple interest just means that we find, in this case, it'll be 5%. We find 5% of 4,000, and that's what Pavel will earn every year. We'll just add that on and add that on and add that on and add that on each year, and the amount we add on won't change. So 5% of 4,000, which is what we're looking to find. So 5% of 4,000, as we've done all along, we can convert that into algebra. So 5%, 5 over 100, of means multiply, of 4,000. Well, I can just begin cancelling that down, and the 5 times the 40 that we're left with will mean that it'll be 200. So the amount of interest Pavel will earn will be $200 every year, and that will be the same every year. So you'll start with $4,000, and at the end of year 1, he'll have 4,200. At the end of year 2, if we were to keep going, I know this question's only about 1 year, but if we were to keep going, Pavel would have 4,400 after year 2, 4,600 after year 3, 4,800 after year 4, and it would just keep going. He would get $200 every year, no change. So in terms of this question, we are looking for how much does he earn after 1 year. well, we can say that Pavel, after 1 year, would have his $4,000 original plus the 200 he earned in interest. So Pavel's sitting at 4,200. Well, let's tuck that away and we'll use that later on. Now we go looking at compound interest. Now this is one where the amount of interest you would earn will change with time, because we take that interest and put it back on top of the principal and then take the interest rate off that. Now, the thing to look out for is this: when is it compounded? How many compounding periods do we have? So in this case, we're looking semi-annually, but we're only looking for 1 year, so we will have 2 compounding periods. Now, there is a formula. There is a huge, great compound interest formula that we get with this one, where we could say the future value is the present value multiplied by 1 plus the interest rate over 100 times the number of compounding periods to the power of the number of compounding periods times the number of years. As we've said before, yes, there are formulas for these things, but do you want to have to remember that formula perfectly when you're on question 30 of the exam and the clock's ticking away, particularly in this one, where you're going to end up having to do 1.025 squared. And that sounds horrendous. I certainly don't want to have to do that level of horrible arithmetic as the clock's ticking down. And if we can get to the stage where we understand the process behind what's going on in these questions, yeah, you might write a few more lines of algebra, but the likelihood of you making a mistake diminishes rapidly. And so the way that we can work with this one is that, I can say we're dealing with 4,000 at a 5% interest rate here. So I could say that, well, as we've seen up above, 5% of 4,000 is $200. Now, we could say that Vlad, if he invested $4,000 at 5% interest for 1 year compounded annually, so no compounding periods, just that one period, $4,000 at 5% for the 1 year, he would earn $200. But we're going to compound this semi-annually, so we're going to compound it after 6 months. So that would be half of the full year. So rather than earning $200 in half a year, Vlad's going to earn $100. Now then we're going to take that amount, 100, and add that to the 4,000. So in the second compounding period, in the second half of the year, he's actually going to be dealing with 4,100, and it's as if we invested that at 5%. Now again, if that was invested for 1 year, then he would earn $205. But we only have the second half of the year to deal with. So he's only got that invested for half a year. So he's only going to earn half of that $205, or he's going to get $102.50. Now I can take that $102.50 and add that on to the 4,100 we started with. So the total that Vlad has at the end of the year is going to be $4,202.50. Now this process of saying, well, okay, what would I earn if I invested it for 1 year? How much of the portion of the year do I have? In this case, it's semi-annually, so I'm using a half, so we divide the 200 by 2. But if this was compounded quarterly, I would divide the 200 by 4, add that on, and I would have to go through this process 4 times to take into account each quarter of the year. If it was compounded monthly, I would do the 200 divided by 12, and I would have to go through this process 12 times to get through the entire year. So yes, it's going to take more time, but it means that the algebra and the arithmetic are more simple. As I say, if we were to use the formula in this question, I'm doing 1.025 squared, which is going to be horrible. And then I've got to multiply whatever that comes out by my original 4,000 times 1.025. Again, the numbers are going to get horrible very quickly. Whereas when you're working down this way, yes, it's going to take longer. Yes, you're going to do more writing, but you're going to be able to keep track of where you are in the question. The numbers involved are a bit more simple, and you're much less likely to make a mistake. So to come back to this question, we know that Vlad's total was 4,202.50, and I want to know how much more does Vlad earn than Pavel after 1 year. So the difference between them is going to be the 4,202.50 that Vlad earned minus the 4,200 that Pavel earned, which means that the difference between them is 250 And so my answer to this question is B. Right, so yeah, I hope that made sense, the difference between simple interest and compound interest. Simple interest, you just get one value at the beginning, you just add that on each year, or each, however often you're compounding the interest. Compound interest is a bit more complicated, and yes, there's a formula, but if you understand the process behind it and what's going on, these questions are much less complicated. They're less intricate. The algebra, the arithmetic is less nasty, and you can keep track of what's going on rather than just blindly following a formula and hoping that it works out. And we're going to take that compound interest idea on and play with it a little more in the next couple of questions. So I will get rid of this one, and I'll see you back here in a couple of minutes' time. Okay, this is a very heavy algebra question, so if you need a little more time to crack this one, feel free to pause the video now, but I'm going to take it away so that we can take a closer look at this one. All right, so as I've said, huge amounts of algebra here. I hope the thing that you've noticed there is that we're given this value p in the question, but then none of the answer choices have any p in it. Now, the way that it's presented means that you're likely to use this p-value throughout your solution, but at some point we're going to have to eliminate it, and that's the clue we're going to use as we go through this question. Now, what the scenario we've got is a car is losing value over time, so I'm going to build up this solution by looking at how things change across time. So I'll start on January the 1st, 2019. We're told that the value of this car is $80. And this changes, it loses a fixed percentage P of its value every year. Now, the process that we're going to follow here to get to the next year is exactly the same sort of thing that we've been doing throughout this video. But up until now, I've known what the percentage change I'm applying is. For example, if the car was going to lose 25% of its value, then I would say, well, 25% decrease, that's the same as 100 minus 25%. So I've got 75% of the original value. Turn that into 75 over 100 times by A. That's what I'd like to do, but I can't do that here because I don't know what P is. But I'm going to follow through the same sort of process. So on January the 1st, 2020, I've got my original value A, and I would like to multiply that by the percentage of. What new percentage of it? As I said, if I decrease by 25%, I have 75% of the original. In this case, I'm going to decrease by P%, but I don't know what P is, so I can't take that off the 100, but I can represent it in the same way. 1, that's the same as 100%, 100 over 100, we could just write as 1, minus P%. Now that would be the percentage of the original. And as I said, if you're decreasing by 25%, this would be 75% of the original. But I don't know what P is, so this is the best I can do. But I know that the value on January the 1st, 2020 is going to be A times 1 minus P over 100. Now, if that's the price on January the 1st, 2020, then the price on January the 1st, 2021 would be this value that I've arrived at. And then I'm going to reduce that by P% again. So I would multiply that again by 1 minus p over 100. Now, because I've got the same thing in both these parentheses, I could say that's 1 minus p over 100 squared. And we begin to build up a pattern here that as we go through time each year, I would multiply the value I had by 1 minus p over 100. So after 1 year, I'd have a times 1 minus p over 100 to the power of 1. After 2 years, I'd have a times 1 minus p over 100 to the power of 2. And so that can take me through to the third year, when I'd have a times 1 minus p over 100 to the power of 3. But we're told what the car's value here in that year. That's worth $B, so that equals B. Now, up until now, I've just been building up this pattern. And the question is, how much will this car be worth on January the 1st, 2023? So I'm actually going to change what I do here, and say, well, I'm going to take that B value and multiply that by 1 minus p over 100. Now that gives me an expression to start with. January the 1st, 2023, the value of the car is B times 1 minus p over 100. But as we said at the start, none of the answer choices have any p values in them. They've all got variations of A's and B's. So I've got two equations, and I'm going to have to use those to get rid of the 1 minus p over 100 in this final one and see what I end up with. So if I take this value from January the 1st, 2022 and say that A is 1 minus p over 100, sorry, A times 1 minus p over 100 cubed is equal to B. If I divide both sides by A, and then take the cube root, I've made 1 minus p over 100 the subject here. And I can take this value and substitute it back into my value for January the 1st, 2023, and that'll get rid of anything with a p in it. So I've got B times the cube root of B over A. Now I can rewrite that cube root of B over A as B times B over A all to the power of a third, which is B times B to the third all over A to the third, or simplifying the exponents there, B to the power of 4 over 3 over A to the power of a third, which, comparing it to the answer choices, means that the answer here is D. So we've stepped up the difficulty level a little bit here. This is about turning those percentage changes that we dealt with before from numerical values into algebraic ones, and still being comfortable with multiplying by the percentage, the new percentage value that we're dealing with. If you can get your head around this, then you can deal with many multiple percentage change questions, even involving lots of algebra. All right, I've got one more question for you. Again, we're dealing with multiple percentage changes and interest rates and various things like that. So I will get the final question up on the screen, and I'll see you back here in a couple of minutes' time. Okay, now's the chance to pause the video if you need more time to take a look at this one, but I will take it away so that we can take a closer look. All right, so yeah, lots and lots going on in this question. In the end, we're going to be dealing with some compound interest again. So we're going to dig deeper into how that works. But first job here, I'm going to make things more simple. All the numbers here, so 9.6 million users, and they gain 400,000, 425,000, 475,000. Things are going to be a bit nicer if I divide everything by 1,000. So we've got our users. I'm going to say we're starting with 9,600. And there are increases in the second, third, and fourth quarter. Well, if we divide everything by 1,000, it'll be 400, 425, and 475. The numbers will still work out, right? Now, what we're aiming to do here is increase this number by 16 2/3%. I know how much I get in the second, third, and fourth quarter. And eventually, when we get to the solution, I'm going to want to know what was the annual rate of interest, approximately what annual rate of interest would the company have needed in the first quarter to ensure they reached their goal. So we're looking at that first quarter. I know what happened in the second, third, and fourth. I'm looking at that first quarter. If I want to know the percentage rate of increase I would need above and beyond that 9,600, I'm going to need to know what the absolute number of new customers I would need in order to work out the percentages. So that's our first job. Now, if we're starting with 9,600 and I want to increase that number by 16 2/3, well, that means that our overall target, our annual target, is going to be 9,600 increased by 16 2/3%. Or in other words, I'm increasing this by a sixth. Now, a sixth of 9,600, that's 1,600. So my target for the year is to increase by 1,600 users. Now, I know that in the second, third, and fourth quarter, I get 400, 425, and 475 users. And if I subtract all those away from the 1,600, that'll tell me how many users I need to gain in that first quarter. So in this case, if you do that subtraction, we should end up with 300 users. That's how many I need in the first quarter in order to make this target work. And what I'm looking for is the annual rate of increase that will get me to that value if this figure is compounded every quarter. Because I'm only looking for the annual rate of interest the company have needed in the first quarter. So this is a compound interest question. We've got 1 year and we've got 4 compounding periods. So we're going to work this in a very similar way to the Vlad and Pavel question, except what we know and what we don't know is different. So what we would do with this, if we're going to use compound interest here, I would say that there is some unknown percentage increase in that first quarter, and that's what we're going to go and find. Now, the way we would work this is we say X% of the 9,600. That would give me some percentage value. That would give me some number. That would be the annual increase I would get if I was remaining at this percentage. But the way this works with the compound interest is I'm only having that interest rate for I've got a compounding period in that first quarter of the year. So I'm going to take that overall increase, whatever it was, and I would divide that by 4 because we're only having 1 quarter of a year. So we would take whatever that value is and divide it by 4. And that would tell me how many new users I would gain in that first compounding period. Now, the good bit is we know that. We know that the number of users we're going to get in that first compounding period is 300. So whatever this value is, let's just call it V there. If we divide it by 4, we get 300. So this original one would be 300 times 4. We'd get 1,200. So at the percentage rate we want, if it was 1 compounding period over a year, we would get 1,200 new users from our 9,600. And so what we need to do now is go and turn this line into an equation and go and find X. Now, thankfully, we're bringing all the skills we've done so far because I've written this in such a way that I can convert straight from the text into algebra. As you can see here, X% of 9,600 equals 1,200. So I could write that as X% or X over 100 of, so multiply, 9,600 equals 1,200. And now, as we've done before, we can cancel wherever we can. I'm going to divide by 100 on both sides just by cancelling out those zeros. And we could say that X over 100 is 12 over 96. And now again, it's a case of simplifying as much as you can here. We can divide top and bottom by 12, and so that's 1 over 8. Now what I've got, x over 100 is equal to 1 over 8, or x is 100 over 8. Again, now it's just a case of cancelling down this as much as we possibly can. I could divide top and bottom by 4, so that's 25 over 2, which is 12.5. And that would be the interest rate the company would need, the annual interest rate the company would need for that first quarter in order to meet their target, which means that our answer to this question is D. So yeah, as you can see here again, we've got a compound interest problem here. We've got an annual interest rate, but it only applies in the first quarter. So we would have 4 compounding periods in this year. Yes, there's a great big formula that you could use in order to work your way through this question. The algebra is going to get quite nasty. There are plenty of places to make a mistake. But if you can understand how this compound interest process works, as we said before, it's going to take a little bit longer. You're going to have to put more steps in, but you're far less likely to make a mistake. As you can see throughout this, yes, it's a tough problem, but the algebra itself isn't that complex. And so if you can get your head around the concepts here, if you can understand exactly what we're aiming to do with this compound interest work, then you can make your life easier. You can minimize the chance of making an unnecessary mistake. And it's that skill that will help you on the GMAT. Missing a difficult question, far more damaging to your score than missing a very difficult one. And so if you've got the opportunity to minimize an algebra mistake, arithmetic mistake, I would take it. All right, so yeah, I hope this has helped you understand percentages a little better. As we said at the top, I think the key things you can take away here are from the text, translate as literally as possible and make fractions your friend. As much as possible, stay away from choosing a starting value and using that to work through the problem as you go. If you can stick to the algebra, turn everything into these fractional multipliers, simplify the fractions as you go, you're far less likely to make a mistake. All right, that's all I've got for you today. We'll hopefully see you back here again soon for the next in our GMAT Ninja Quant series. Thanks very much for watching, everybody. We'll hopefully see you back here soon.